So we're told that we have a figure with points A, B, C, and D in it, and they're all collinear. So what that collinear word means is they're all in a line. And you could tell they're all in a line just from looking at the graph. And then we're also told that CDE, okay, CDE measures 75 degrees. So, well, let's put that in this plot here. CDE, what is that? That is this angle right here. Okay, that's 75 degrees. And we're told that BEC measures 48 degrees. BEC. Okay, so what is that? That is this angle right down here. That's 48 degrees. And if you're taking a test and you're allowed to write on the paper, I would encourage you to do that because that makes this a lot easier if you can see the numbers written down in a picture. And then ABE measures 151 degrees. Okay, so what is ABE? That's this guy over here, this wide open angle. And if you note in the picture, it says figures not drawn to scale. I would keep that in mind when you're doing these sorts of problems. When they want to know the value of DEC, okay, what are they looking for here? Let's draw that in blue. DEC is going to be this teeny little angle right there. Don't try to estimate what it is by looking at the picture. It's not a good way to do it. We have to use properties of triangles to figure this out. So if I know two angles in a triangle, I can figure out the third angle of the triangle. That's just some basic triangle geometry. The trick is finding out two angles in CDE. So triangle CDE needs two angles. And once I have two angles in that triangle, I can figure out a third angle. So let's see if we can figure out two angles in that triangle. I don't know, kind of tough. Maybe triangle BEC. I just need something. Once I figure out something, I can probably work my way through the rest of the problem. There's only one angle in this one. It's that 48 degrees. Okay, so what am I left with? Okay, 151 degrees. Right here. How can we use that? Well, if you remember, right at the beginning of the problem, they said A, B, C, and D are all collinear. That means this is a line right here. Okay, and if that's a line, it means it's 180 degrees. That's how far you go around when you measure a line. It's like a half circle. So if that's 180 degrees and this right here is 151 degrees, then this has to be the difference. This angle right here, CBE. So I'm going to say angle CBE equals 180 minus 151. And that's equal to 29 degrees, I think. Okay, so that's 29 degrees. Well, that's great because now look at what I have here. I now have two angles within a triangle, 29 degrees and 48 degrees. And I can use that to figure out this angle right here, angle BCE. So angle BCE now equals 180 minus the sum of those other two angles, 29 plus 48. And I think it's calculator time. I don't want to make a mistake here. 29 plus 48 is 77. And 180 minus 77 is 103 degrees. Okay, so that's 103 degrees. 103. Well, if that's 103 degrees, then I can figure out this angle right here. Let's use magenta. This angle right here is going to be 180 minus 103. So that's going to be, I can probably do this in my head, that's 77 degrees. Okay, so now I know that magenta angle is 77. And I know the angle right next to it is 75. So that tells me the last thing I need to know, which is DEC. Angle DEC equals 180 minus this sum, 77 degrees plus 75 degrees. And once again, let's pull out the calculator. 77 plus 75 is 152. 180 minus 152 is 28 degrees. Okay, so that is our answer. Took a little while to get there, but the way you go through a problem like this is you just find angles that you can make statements about. Okay, the first one I used was this straight line right here that I knew had to be 180 degrees. So that told me 29 degrees. Then I used 29 degrees and 48 degrees to figure out another angle right here. And then on and on we went through this daisy chain of statements about 180 degrees.